Black holes are spherical masses so large that nothing, not even light, can escape from their gravitation. To understand black holes, we need to understand two things. First, what a black hole does to the fabric of space-time, and second, what happens to the mass inside the black hole. Based on the fundamental principle of the relativistic universe, which is explained in my other talks, a black hole is simply a spherical volume of space where the intrinsic spatial velocity of the gravitational field is equal to c, the maximum possible, and as a result the velocity of time is zero. Thus black holes are uniform volumes of space with the maximum possible intrinsic spatial velocity. And they're completely solid. They contain all the matter that fell into them, and they have no space-time singularities, where the laws of physics break down. As always, nature, properly understood, is simple, commonsensical, and non-paradoxical. The matter within black holes is compressed to the maximum possible extent, at least into neutrons, as in neutron stars, more likely to a quark-electron plasma, depending on the binding energies relative to the gravitational compression. In any case, a black hole is a solid uniform mass, and its matter certainly doesn't vanish into other universes, which there's no reason to believe even exist. Observer views. How black holes seem to behave depends on the relativistic situation of the observer. In relativity, one must always distinguish what is actually happening to an observer or event itself and how that event is seen by other observers from other relativistic situations. This is because we observe with light and time, both of which are affected by relativistic conditions. Though black holes are actually straightforward non-paradoxical objects, they do appear very differently to different observers due to their extreme effects on the velocity of light and clock time. First, from the point of view of the universe as a whole, objects simply fall into black holes with enormous velocities. They fall so fast through such an enormous gravitational gradient, they are ripped apart into their molecules. However, from the point of view of an observer outside the black hole, things look very different. As a falling object approaches the event horizon of a black hole, it takes longer and longer for its light to reach the observer. So he sees the object seem to fall slower and slower until just outside the event horizon, the light takes almost forever to reach him. Because of this, some physicists mistakenly claim that objects seem to pile up on the event horizon and just sit there forever. Not true. As infalling objects reach the event horizon, light takes longer and longer to reach the observer, which means less and less light reaches the observer, so infalling objects simply fade away and disappear. Not only that, but the light from the object also becomes redder and redder due to the extreme gravitational redshift and also fades off the bottom of the spectrum. Now, what would an observer falling into a black hole experience? His clock time rate approaches zero as he falls towards the black hole, so it seems to take much longer than it actually does. And his clock time stops as he crosses the event horizon, but by that time he's been ripped apart and compressed at least into his neutrons anyway. Black hole nonsense. All sorts of nonsense has been written about black holes, even by physicists who should know better. Some claim a person falling into a black hole doesn't notice anything at all, but this is total nonsense as he's ripped apart into his atoms and dies. And rather than passing through the event horizon into an empty space, his remaining particles smash at nearly the speed of light onto the maximally dense surface of the hole. Also, most physicists believe singularities exist at the centers of black holes where the laws of physics break down. But this is more nonsense based on the mistaken idea that space and matter are infinitely compressible. But as we have seen elsewhere, space can only be compressed to the point where its intrinsic spatial velocity becomes equal to c and its temporal velocity is zero. Other physicists claim black holes might be portals into other dimensions or other universes, but nothing can escape a black hole, and there's no evidence of other dimensions or universes. This claim assumes that all the mass falling into a black hole somehow disappears through its central singularity, but that doesn't even exist. Equally ridiculous is the notion that black holes might be entrances to wormholes, shortcuts to far reaches of the universe, other times, or other universes. Again, black holes are filled with solid, maximally dense mass, and wormholes violate both the universal current present moment and the c velocity of space, and therefore they can't exist. So black holes aren't empty spheres with central singularities, as many believe. They are simply uniform spherical volumes of maximally compressed mass whose gravitational fields of intrinsic spatial velocity equals c, and therefore reduce the velocity of time to zero within them. That's nothing. Not even light can escape a black hole because it would have to travel faster than light, which is impossible. Thus, like all aspects of the real universe, black holes completely obey the normal laws of physics and aren't paradoxical at all.